Welcome to A-Level and AP Physics. In today's lesson, we will talk about Gold Leaf Electroscope. We will discuss how electroscope works with the help of experiments. And we will also try to understand concepts of static electricity with the help of electroscope. You can also say electrometer. This video will help you to improve your conceptual understanding of static electricity. Let's study together. Let's improve together. First of all, let's try to understand some basics of electroscope, so you can see the main parts of the electroscope and also you can understand some basic concepts about electroscope. So first of all, you can see we have this ring. This one is the charged probe, or simply you can say this one is the charged rod, you can also simply say. And here we have plate. So this is the plate, this is metal plate. So these are the parts of the electroscope. So simply we have a metal plate, and here we have insulator. So at this point you can see we have insulator. The purpose of insulator is to prevent charge to spread over the body of the electroscope. So that's the reason we have, at this point we have insulator. So this will prevent charge to spread over the body of the electroscope, means over this part of the electroscope. So this is the body of electroscope, so it will prevent charge to spread over this body of the electroscope. So very important point, you need to understand why we're using insulator. And here we have, this is the metal rod. You can see this metal rod is passing through this insulator, so we can say this one is metal rod. And here we have, this is metal leaf, we can say. So this one is the metal leaf. So this is basic structure of electroscope. So if you're clear with this structure of the electroscope, now let's try to understand the physics of electroscope. First of all, you can see this is positively charged. So here this has net positive charge. This has net positive charge. But this electroscope, this one is neutral. So very important point, you need to understand this one is neutral at this point. So I can say this one is neutral. Electroscope has no net charge. So if we bring the positive rod closer to this electroscope, we need to understand what will happen. If we move this one now, so this rod is positively charged, so you can see in this case electrons are attracted. So we can try to understand the physics behind that. So you can see this part here, this is positive because this rod is positively charged, and this part of the plate, this become more negative, so simply we can draw these negative charges here. These are representing electrons. It means more electrons closer to this positively charged rod. And these electrons, you need to understand, these electrons are coming from this metal leaf and they are coming from the rod. So electrons from here. So before we have electrons here, so you can simply imagine we have electrons here. So because this leaf and the rod, initially they are neutral, means they have the same number of positive charges and they have the same number of negative charges initially. As we bring this rod closer to electroscope, electrons are attracted because this rod is, this probe is positively charged. So these electrons, they move from here and they reach this plate. So now in this case we can simply delete these electrons. We can simply delete, so you can have better idea. So these electrons, they leave this leaf and they leave this rod. So we have net positive charge on leaf and on the rod. So due to repulsive force, they deflect away from each other. So this is what is happening here. Now we need to understand is that, is this electroscope, very important question, very confusing. Most of the time students, they are confused about this. So we need to understand if this electroscope is still neutral or not. So what is the net charge on electroscope? So let me ask you this question. net charge on electroscope at this moment. Net charge on electroscope. So very important point you need to understand. What is net charge on electroscope at this instant? Is it positively charged? Is it negatively charged, or is it neutral? So you have three options. You can choose one of them. You can pause the video and you can try to figure out what is the net charge on electroscope at this instant. So I hope you will say it's neutral, because no electron is transferred to the electroscope and no electron leave the electroscope. So electroscope still is neutral. If you take this one, it means your understanding is clear. So it is still neutral. So we can see this one, why it is still neutral. So we can simply move this rod away. So you see it come back. So now the question is that why this come back again? Why this come back again? So very important one. You see movement of electron, the movement of blue dots. You see electrons will come down now. You will see electrons are coming down. They will make the leaf and the rod neutral. So that's the reason there is no repulsive force and it will come back. I hope this point is clear to you. So electroscope is neutral all the time, because in this case rod doesn't touch the electroscope. So there is no net transfer of charge, or you can say no net transfer of electrons, because only electrons move. Positive charges do not move. Means proton, they're fixed with atom, they stay in the nucleus. They cannot be easily removed by just rubbing due to strong binding forces. I hope this one is clear. Now let's go to the next point. Let's say when this one is neutral, what will happen? You can predict by yourself. If rod is neutral and electroscope is neutral, we bring closer this rod closer to the electroscope. What will happen? You can predict by yourself, and then you can see nothing will happen, because neutral, no net charge, means if no net charge, these two objects, they will not repel each other. One of them has to be charged. One of them must have net charge. So then there will be repulsive force. Now if there will be attractive force. If one is charged and other is neutral, there will be attractive force, means electrons will be attracted or electrons will be repelled. It depends. So there will be attraction. That's the reason pieces of paper, I'm saying attractive force, because pieces of paper you can attract with positively charged rod, you can also attract with negatively charged rod, because there is attractive force. But if you look at electrons, between electrons there can be repulsive force, there can be attractive force. If this is negatively charged, this will repel electrons from the plate and electrons will go to the metal leaf and rod. And if this is positively charged, it will attract electron from the leaf and from the rod, and this plate will be negatively charged. So point is very important. Okay, I hope until it is clear to you. If you have any questions, you can leave your questions in comments. So this is charging by induction. Let's go to negative. Now if negative rod I bring closer, you can predict by yourself first of all. So if negatively rod we bring closer, the plate will be positively charged. Electron from this plate, they will be repelled. So you can look at these blue dots. You can see the blue dots here. So we have more blue dots. You can see at this point. You can see we have a lot of blue dots. So it means this one is negatively charged. The net charge on this leaf and net charge on this rod is negative. So that's the reason they repel each other, and the net charge on this plate is positive. So net charge on this plate is positive. There is attraction between positive and negative charges, electron, or we can say there is electric field. But electric field concept little beyond your understanding at this time, so we will not talk about electric field a lot. So I just want you to understand the basics of electroscope. So if I ask you now, what is the net charge on this electroscope? I hope again you will say net charge on electroscope is 0, mean electroscope is still neutral, because no charge is transferred to the electroscope, or no charge has been transferred from the electroscope, as there is no loss and gain of electrons. That's reason electroscope is neutral. So electroscope is still neutral. And now also you can predict, if I move this rod back, how about leaf and this rod? They will come closer or they will not get closer. You can predict this one by yourself. So if I move this rod up, you see they come back, and you will see electrons from here, they will be distributed over this plate and they will make this plate neutral. I hope until now you have clear understanding of electroscope, and we will do 2 more questions about electroscope to make sure you have good understanding of electroscope. Now let's try to understand more about electroscope and static electricity with the help of real experiment. In this experiment, I'll be using ebonite rod and fur. Fur will be positively charged. Fur will be positively charged because fur will lose electrons, and rod will be negatively charged because rod will gain electrons. If you look at triboelectric series, you can see the fur is at the top, means fur will be positively charged. It has higher tendency to lose electrons, so that's the reason fur will be positively charged, because it will lose electrons. Now look at this experiment and try to understand what is happening. So you can see, first of all, I'm rubbing the rod with fur, and focus on electroscope. And if you look at electroscope, you can see this leaf, it has been deflected. So this one is the leaf. If you can't see in this video very clear, so this one is the leaf, so this leaf has been deflected, and here we have this rod. So you can see it is more than around 30 degrees. It is deflected by this angle. You can see its deflection increase as I move this rod, and when I remove the rod, it come back. So you can simply say here, this one is neutral now, and before it was also neutral. So very important point. So in this case, we are just placing the rod at the top of the plate, and the rod is not touching, so there is no net transfer of electrons from electroscope or from the rod. So that's the reason this electroscope was neutral before, and it is also neutral after. So very important point. Let me explain you a little bit about this. In this case, we have said this rod is negatively charged. So this is negatively charged. When you bring closer, this plate will be positively charged, because it will lose electrons will go down, so they will make this rod negatively charged, and they will make this leaf negatively charged, so they will repel each other and we will see deflection. And when we remove this one, these electrons, first of all, these electrons came down, and when we remove this rod, these electrons will go back, mean they will make the plate neutral. So we can draw arrow here, they will go back. So this is what you need to understand. Next one, we will do one very important experiment. So let's move on to the second one. Now let's try to understand, if we place our hand on the plate, or simply if we connect ground with the electroscope when the rod is there, and then we remove the ground, or means we remove our hand from the plate, is electroscope is still neutral after removing the rod or not? So you can predict this one by yourself, and then we will discuss, and you can come back and you can listen my explanation. So first of all, you can watch this video. You can watch this one and try to understand. You can see I place my hand, so the leaf come back. Now I will remove my hand, I will keep the rod there. So now the question is that, is this electroscope still neutral or not? You see, in this case, leaf is deflected. Leaf doesn't come back to the original position. So it means that this one is charged. So from here we can conclude that this one is charged. So this is charged. If rod was negatively charged, so this one will be positively charged. So rod, in this case, we are saying rod is negatively charged. So electroscope is positively charged now. So negatively, so electroscope is positively charged. So electroscope is positively charged. So let's try to understand the physics behind that. So first of all, we have this negative rod. So here we have negative rod. So this plate becomes positive because electrons from this plate will be repelled. So electron will go down. So these leaf and the rod, they will deflect because they will have net negative charge. So let's go back to this video and let me explain you with real experiment. Okay, this is the point we need to understand now. So in this case, you can see when I place my hand, so this rod was negatively charged. So we can draw, this is negatively charged. And this one is positively charged. And this one was before negatively charged. Now when we place hand on this one, these electrons from this leaf and from this rod, they will go away. They will be transferred to the hand, then they will go to the ground. They will go to the ground. So it means electroscope has lost electron. Lost electron. So electroscope has lost electrons. Electroscope. So electroscope in this case is losing electron. So electrons will be transferred to the ground. Now if we remove our hand, first we have to remove the hand and then we remove the rod. So this will be positively charged. So this will be positively charged. So this is the point. So in this case, electroscope is losing electron. So this is the main concept you need to understand. So this will be positively charged. And vice versa is also true. Now let's say if the rod is negatively charged, so electroscope will be positively charged. So this is just charging by induction. Very basic principle, charging by induction. So this is what is happening in this case. So this is charging by induction. Very simple concept, nothing more than that. Charging by induction. This is most of the time what we do. For example, if we have a sphere, so let me explain you quickly. Let's say we have this sphere and we have in this case negative rod. So this one you can imagine, this is a negative rod. So if we bring this negative rod here, this side become more positive, this side become more positive of sphere, this side become more negative. Now in the second step, so let me redraw this. If we redraw here again, so this side is more positive. Here we have our negative rod. So this is negative rod. This side is more negative. Now if we connect this one with ground, so here we have ground. If we connect this one with ground, these electrons, they will be transferred to the ground. They will go to the ground. They will go to the ground. And we can redraw this. We can redraw again here. So we can redraw here. So we keep our negative rod here, negatively charged rod here. So this is positive, this is positive. This lose electron, so mean this become neutral, and this is connected with the ground, connected with the ground. So now if we disconnect this one, if we disconnect the rod, mean disconnect from the ground, this sphere, and now if we remove the rod, if we disconnect ground first, means you have to remove your hand first and then you remove the rod. So you will see this sphere will be positively charged, and vice versa is also true. I hope this one is clear to you. I tried to explain you in a simpler way and in a beautiful way so you can have better understanding. I hope this one is clear to you. If this video was helpful, please like and subscribe so I can upload more videos for you. See you next video. And also, if you have any questions, please leave your questions in comments.